3, 2. Okay, so power function transformations. Now, you have studied transformations in grade 11. You have studied it again, okay, in advanced functions in grade 12. Now, as you carry on and you move into polynomial kind of a review, which I believe was done in grade 11, but hey, in advanced functions, you do it again. You know, it's still wise to probably get comfortable with transformations for power functions. All right, so our power function that we have, okay, so it's x to some power of n. You know, typically we may put some kind of a constant in front which scales it, okay, and maybe reflects it, but we can do much more, right, in terms of transformations. So I have done a full-out step-by-step video for advanced functions in grade 12 in transformations, and it basically followed these particular steps for any parent function you have. So if it turns out that your parent functions are actually power functions, I mean, honestly, even easier, okay? Because they all kind of scale to the same thing, and I'll show you that in just a moment. So I'll put up a link up above to that step-by-step to transformations if you haven't seen it. But if you have, you know, watching this video hopefully is going to give you a little bit of more comfort, all right, with respect to power parent functions. So when we are studying power functions, and so here I'm going to just highlight it right here, where that n is, you know, it can be 1, 2, 3, 4, 5, and so on. So basically some whole number. Now, when it's 1, then we just have a line, right? When it's 2, we have a nice quadratic parabola. So those ones, I mean, you have studied more than enough, right? Now, if it's a 3, you know, we have a cubic. If it's a 4, I guess it's called quartic, okay? And it continues on. Now, I'm going to only take the cubic, and I'm going to only take the quartic, so x to the 3 and then x to the 4. Because anything that follows afterwards follows exactly the same process of transformations, and in fact, they pretty much look identical, all right? So if you go from x to the 3, x to the 5, x to the 7, so when they're all odd, they look very similar. And then when they're even, so x to the 2 and then x to the 4, x to the 6, and so on, again, they look very much the same. So I'm just going to show you that. Again, you've seen it in the previous video on power functions. Okay, I'll put up a link to those power functions there, but let me just show you again. All right, so, you know, here it is. So we're in Desmos, okay, and we have x to the n. So notice that's, of course, just a line. Okay, when it's 2, we know that it is basically just a parabola. Okay, 3, you know, it's the cubic, so it kind of looks like this. And then when it's 4, it's going to look, again, like a parabola, except it gets squished down at the bottom, okay, because the smaller numbers under the magnitude of 1, you know, really gets pushed down because they're x to the 4. And then the bigger numbers kind of get stretched up. Okay, but it looks very much like a parabola. So like if I would draw a parabola in here, right? So notice that's how it is. Okay, so that's the difference. The green one is the parabola, and then its quartic is the red one. So it gets more stretched out. And it makes sense because it's a higher power, and then it gets squashed down below 1. Okay, now if you continue on in this pattern, so as I said, so to the 5, again, it looks kind of like your, you know, cubic. Again, it gets squashed down at the bottom and then stretched out, and then it keeps going. So notice 6, and then 7, you know, and 8, okay, and 9. So all you're seeing really is, you know, towards the 0, okay, they really gets kind of squished down there, and then they really start to blow up, but they kind of look the same. So all of those parent functions can be really just captured by 2. Right? So there's only 2 differences. When it's an odd, so when n is an odd number, in this case, so 3, 5, okay, 7, and 9, and so on. Or, again, I'm going to do to the power of 4 because we've done enough parabolas already, although this is kind of like a parabola as well. So when they're even, so 2, 4, 6, 8, 10, 12, and so on, they always look kind of like a parabola, all right? So if we go back in here and we want to be able to do the transformations of these, the steps are no different, okay? So when we have this as a whole. So notice if we take our power function and we multiply it by a, so so if I went back in here, okay, and then I stuck an a inside of there, then RA, so right here, so if the magnitude is between 0 and 1, okay, we know what actually happens. So it's going to get kind of, in this case, it's going to get kind of squished down, okay. If A is greater than 1, it's going to start to get stretched out. And now this one, okay, when it's negative, so if it is negative, then it's just a reflection, right? So we would see that it's just reflecting in the x. So that's exactly the same thing as all transformations, and that's kind of nice. Now, if we start doing a little bit more with these power functions, so now what if we stick in a d in there, right? So the d, again, there's a stretch and a compression, okay, kind of in the x, as you will see. And then there is a reflection if d is negative, except that reflection is in the y. So for our even power functions, we really don't see any reflection because it's a mirror image of itself, okay, on both sides, so even if it's flipped, all right? And how this looks like, so if I take this and rewrite it, so sure, so we'll have our a, okay, and then we're going to start sticking in here, okay, so here's our d, okay, our x, okay, and then this is to the n, all right? So this is our d right here that we are sticking in there. And then what can happen is, as you carry on, so you can then do translations. So you have one translation through the h and another translation through the k. So the h is going to translate along the x-axis, so it's going to shift the power function left and right, depending on if h is positive or negative. And then your k always is moving it up or down. So this is, now you've seen it through grade 11 numerous times. You've seen it in the introduction of advanced functions for several functions. And now you're seeing it again for power functions. All right. So, if we write it down in full for our power functions only, so what we would have is we would have f. Now it's going to get multiplied by a. Then we have a d. All right. And then this is x minus h. So if we put that, this is our power function. So I apologize here. This is my f. Let me shift this over. Okay, so this is going to be to the n and then plus your k. And then one by one, we can see what all of these, okay, will be doing. And we can do that in Desmos because by now, you should be comfortable in Desmos and moving these up. But if you had to sketch it, again, you should be able to do that as well. All right, so let's concentrate on two of them. So, we have so it kind of looks like this. I mean, I'm not the greatest of kind of sketches here, but, it's going to go like that. So this is my x third. Okay, so x cubed, so that's my cubic function. All right, so this is around, okay, that. And then x to the 4 is going to get a little bit kind of look very similar, except it's going to get pushed down in here and then pushed out in this way. Okay, so it looks very close to a parabola. And now this a, again, it's going to either reflect it, okay, and then stretch it in the y. Okay, if a is greater than 1, it's going to stretch, otherwise it's going to compress. The d is going to be stretching and compressing in the x, so we're going to be seeing this kind of getting shifted in here, okay, and then pulled apart in there. And then it's going to also do a reflection in the y for our even, so for our quartic function, it won't make a difference. And then the h is just going to move it to the right or to the left, and k is going to move it up or down. All right, so that's exactly what we're going to see. So let's check it out on Desmos, and you can certainly start plotting them in. So if this is, okay, so I'm going to change this up. So we have a, okay, so this is d and x, I guess, minus h to the n, and then it's plus k. All right, so I'm going to put all of these in here, and let's start with n is equal to 3. Okay, so we're going to do that, and let's zero off these translations. Okay, so a is equal to 1 and d is equal to 1, which basically in this case it's n is equal to 3. This is just a cubic. So that's my parent function. So now one by one, let's take a look and see. So what do we predict, right, will happen? Well, if a is greater than 1, we know that it's going to get stretched out in the y. So notice stretched out. So this gets pulled out like this. Okay, if the magnitude is between 0 and 1, so if I go between here, notice that it gets compressed, right? So it gets compressed in the y. Again, nothing different. Now, if it is negative, you'll see a reflection in the x, right? It just reflects back. So we have a reflection and the same thing happens. Okay, so it just reflects for us. So that's what we have there. So that's my a. Okay, so let me reset a back to 1. For D, same thing. So now we're going to get stretches and compression except in the X. Okay, so now in this case, so if I try, okay, to make D, so in this case I'm going to make D bigger than 1. So notice it gets compressed in the X, compressed in this way, which looks like a stretching in the Y, okay, for us. So that's what happens there. And of course, you can keep compressing it in the X. Okay, if it's less than 1, so in this case, it starts to get stretched out in the X, which is a compression in the Y. If it's negative, then what we're going to be seeing is a reflection in the Y. All right, so then it just flips over in the Y. Okay, so it flips this way. So that's my D. So that's nothing new for us. All right, so let me set this to 1. And then my H, so if I have my H, if it's positive, it's going to get shifted to the right. If it's negative, it's going to get shifted to the left, right? So here, say if I put it at 2, notice got shifted 2 places there. If it's negative 1, it's going to get shifted in this direction, all right? And then the same thing for K. So now positive, it moves up. So let's bring it up, let's say by 3. Okay, or if it's negative, it will move down, and that's what happens. And the same thing happens now. So if I reset this, let me make, instead of a cubic, okay, let's work with a quartic function. So let me do that. And in this case, we're going to see exactly the same thing. So if my A greater than 1, so if I start pulling this apart, what do you expect? You expect a stretch in the Y. Boom, there we go. It's just stretches, so it gets pushed up. Okay, between 0 and 1, it gets compressed, and then it flips over. All right, so this flip in the X, we do see that reflection. In the D, so if I go back to D in here, again, so the same thing. If this is greater than 1, okay, it's a compression in the X or a stretch in the Y. Okay. So, to remember it for A, if it's greater than 1, it's a stretch in the Y. And when D is greater than 1, it's a compression in the X. All right, so that's what we have there. And now, of course, I can go back in here between 0 and 1. What happens, it's a stretch in the X, so it gets pulled out this way. And then if it's negative, so if I keep going, okay, it's going to get flipped. Okay, it's going to get a reflection in the Y. But because it's a symmetric function, the flip, so notice negative 1.08. If I put positive, it's going to look exactly the same. Why? Because it's an even function. All right, so that's what we had there. Now for even and odd functions, if you've forgotten, that was in kind of grade 11. Okay, you had that, and then also in this, okay, of course, you'll see that as well. Okay, maybe I'll put up a link up above there to those odd and even. All right, and then H, the same thing. So it's going to move right or left. So depending, here you go, moving right. Here you go, moving left. Here, moving up and moving down. All right, and that is true for any power function. So they all look the same. So any even ones, so squared, to the power of 4, power of 6, power of 8, and so on. They're going to look very much like a parabola. And then the odd ones, except for x, for n is equal to 1, which means that it's just a straight line. Okay, but for all the other ones, they're going to look like a cubic. All right, so that's what we have there. So that's just a reminder of this. I do suggest that you kind of look and try these out on your own, and if somebody gives you one of these, so for instance, if I just come up with one randomly right here, let's say as an example, and I say, okay, well, try to plot this, okay, on your own without using Desmos, you should know what would happen. So let's say if I put that, and in here, what are we going to do? Let's put it, okay, let's say 3, x plus, let's say 9, and let's put this to the 7, okay? And then, let's say plus 2, like this. So when it is in this form, we can certainly put it, okay, it looks very much like power functions, okay? So this is to the 7, so this is order 7. So it's kind of going to look like a cubic, okay, except it's going to get really squashed down towards the lower side and then really get pushed out because of the power of 7. And then here, so here is your A, okay? Now we have to be a little careful so that we're going to factor out this 3 is going to be x plus 3 to the 7 plus 2. So A equals to -2. So what does that mean? Well, it means that we're going to have a stretch in the y, but also a reflection in the x, okay? So it's going to flip over, so we know that. We have a d, so d is equal to 3. So what does that mean? Okay, that means it is a compression in the x, so it's going to get squished in this way. All right, there is no kind of a reflection at all because it's not negative. Then we have our h, so our h, no, hold on, be careful here because it's supposed to be negative, so it's like this, so this is -3, so that means it would shift to the left, okay? And then my k is equal to 2, so that means this is going to shift this way, and this is going to shift that way. So if I would draw this out, or I would just sketch it out for myself, okay, I'll do a real sketch of this. So the original that I would have, so this was to the 7, so it kind of is going to look, like this. That's my original, so that's x to the 7. Now the a, which is the -2, so that's going to stretch it out. So I know that this is going to get pulled up. All right, so this is kind of going to get pulled up faster, okay, in that direction, like so. But it's also going to get flipped. So, it's going to be something like that. So that's that. My D, so this is now going to get pulled this in. Let me remove these so that we see it. So I just want to be able to see that. So this is going to get compressed in. So that's going to move in this direction even further. It's kind of going to go like that. So we'll see that. This is going to move it over. So this now is going to get shifted over in this way. That's the -3, and then it's going to get shifted up by 2. So it's kind of going to look like this. All right, that's what we have there. All right, okay, let's check it out. Let's see what happens if we actually graph it. So this was to the 7, A was -2, D was 3, H was, I guess, -3, and K was 2. And there you have it. All right, so we kind of were dead on. So that's how it would look like. And you can do that with any of these power functions. So I hope that with these transformations, the step-by-step, you probably had enough of these. All right, okay, thanks for watching. We'll see you in a future video. Bye, everybody.